Hi everybody. As I promised, we're going to start a new unit which I'm going to format a little differently. I'll talk about that in class, so I've gone over it. Unit G, which is right triangles. You have your notes paper, so you can be taking notes along with me. And I'm on number 1 right now, which is typical right triangle vocabulary. That's what it says on your notes paper. So you need to copy down the right triangle and the vocabulary terms that I have here for you. With a right triangle, it means we have 90 degrees right here. We know that from previous math life. We have leg, we have hypotenuse. Those are the vocabulary terms. The two legs create the right angle. The hypotenuse is opposite, and that opposite's going to be important as this year goes along. We need to know the concept of an opposite side or an opposite angle. The right angle is opposite the right angle is the angle opposite the hypotenuse. The side hypotenuse is opposite the angle. So, one of the things to remember about this is usually we call it A, B, and C. For our hypotenuse, that's how you learn the Pythagorean Theorem in middle school or Algebra 1. A squared plus B squared is C squared, and we'll get into that. But you may see that in some cases we identify those sides as X, Y, and Z. Sometimes that's the case. So don't be panicked and say, hey, Mr. S, the sides are not A, B, and C. They're X, Y, and Z. And sometimes that happens. So now we're going to move to section 2, which is Pythagorean Theorem itself. And you remember most commonly that if this is A, B, and C, that the Pythagorean Theorem is A squared plus B squared equals C squared. I know one of you in here has that. When you got your first tattoo, you got the Pythagorean tattooed onto your ankle. Just to make sure you remembered it. A squared plus B squared equals C squared. I like to call it this too. It's really leg squared plus leg squared equals hypotenuse squared. So you should have this information written down on your notes sheet to know that this is the Pythagorean Theorem. And now we're going to get into some teaching problems that show it. So you're still going to have to write down a triangle for each of the next problems. I'm going to keep that up. Actually going to keep this up so we can fit under it. And now let's start working. Number 3 is the first teaching problem. So if I give you a leg of 24 and a leg of 7. This gets to me, actually before I solve it, the right triangle is not going to be to scale. So even though this is 7, which is much smaller than 24, we're just identifying the sides for the purpose of doing the Pythagorean Theorem. So we don't know C, so that's the missing side. What we're trying to do is find the missing side when given two sides. So 24 squared plus 7 squared equals C squared. So this is 576 plus 49 equals C squared. 625 equals C squared. Now here's kind of an important point. To balance this, we are taking the square root of both sides. Something important that you can do is root both sides as part of balancing. And this could be an answer too. Folks, sometimes we're going to leave our answer in radical form. Not in this case. but this would be your radical form if we ever leave it to that. Hopefully you can remember that radical form. So we take the square root of c squared is c, and the square root of 625 is 25, which is our answer. So this length is 25. Something else to notice, the hypotenuse is always the longest side, right? It's always going to be the longest. Second teaching problem. If the hypotenuse is 65 and one of the legs is 63, what's the other leg going to be? You could have put 63 here and solved for this leg, and you could have called this leg A if you want. We're just missing a leg. So, A squared plus 63 squared equals 65 squared. So, A squared plus 3,969 equals 4,225. Take away that, A squared equals 256. A equals the square root of 256. There's our radical form. And when we do the square root, we get 16. Okay? We could also do this. I could give you three sides. That leg is 120. This leg is 90. This leg is 150. And I may say to you, is that a right triangle? Is it a right triangle? And a right triangle would mean that the Pythagorean theorem would work here. So if we did 120 squared plus 90 squared, it would equal 150 squared. So let's do the math and see if the left side equals the right side. And when you do that, you will get big numbers, which is fine. Once you do that math, you will see that they equal out, and your answer will be yes, they are a right triangle. So, that is our third teaching problem right there. That was number 5. And the last one that we have to do is the distance formula. And hopefully I can get this in before the end of the video. -2, 5, and 7, -4. Find the distance between those. Okay? That's what we're going to be doing. And so the distance formula is, if this is x, y, x, y, the formula is x minus x, x1 minus x2 squared plus y1 minus y2 squared. Okay, so how does that fit in here with us? Well, this is x1 and y1, x1 and y2. So we have -2 minus 7 squared plus 5 minus -4 squared. So this is -9 squared plus 9 squared. -9 squared is 81 plus 81. The square root of 162, and that's going to equal 12.7. Okay? Now, I went through that kind of quick, The time is running out. Take your time and watch this part again if you need to.